Hello, my name is Ruxin Li. Today I'll be talking about interpreting dialogue models through local explanation methods. As AI assistants become more commonplace, it will become important to understand and trust their decisions. Neural models such as GPT-2 facilitate the development of open domain chatbots that behave like black boxes and are difficult to explain their complex behavior. Techniques such as localized interpretation of response generation aim to improve model transparency by extracting key input-output interactions that affects prediction. My motivation for this research was to gain hands-on experience in using interpretation techniques to explain patterns of neural discourse. LERC stands for Local Explanation of Dialogue Response Generation. It is a technique specifically designed to explain the internal reasoning of a neural dialogue model to increase the transparency of the prediction process. At a high level, LERC works by identifying significant interaction between input segments such as user words and output segments such as chatbot replies, and determine which input-output relationship are most relevant to the internal logic of the model. I re-implemented key components of LERC in PyTorch. This included first fine-tuning a GPT-2 model on the daily dialogue dataset to create a conversational agent. Then I wanted to see how the explanation would differ for a more task-oriented dialogue genre. So I utilized a new TOD simulator dataset based on chatbot testing tool conversations and preprocessed it into the proper format. With my dialogue model and test sets ready, I ran LERC to extract explanations on both daily dialogue and TOD simulators and evaluated the results using metrics like perplexity and loss as well as visual heat maps of input-output interactions. I also implemented new variation of the LERC loss function to understand how changing the optimization impacts explanation quality. One new variation that I added was LERC sharp mean, which computes the mean of raw probability differences rather than using the differences directly. Taking the mean can help address potential limitations by reducing skew from outlier predictions. Throughout this all-round evaluation approach, I sought answers to key questions. Can LERC accurately capture the salient reasoning of dialogue models? How does the purpose and genre of a conversation influence the quality of explanations? And critically, do the new loss formulation I implemented lead to enhanced results? The results demonstrated that LERC can successfully extract meaningful explanation between input and response tokens on the daily dialogue dataset. This aligns with the expectations and validates LERC's ability to interpret open domain conversational models. However, when applied to the task-oriented TOD simulators datasets, LERC produces weaker and less relevant explanations, as shown in the figure, where gasoline is oddly linked to hot and potato. This negative result indicates that LERC is better suited to chit-chat dialogues compared to goal-oriented ones, confirming my hypothesis that explanation methods need customization for different dialogue genres. Meanwhile, the new LERC Hoover and LERC sharp mean loss variation did not lead to significant observation differences in explanation quality based on the heat map visualization. This fails to validate my hypothesis that they could improve performance and suggest that the original LERC losses are reasonable. In summary, the results showcase the potential of LERC in interpreting neural chit-chat models. However, they also reveal certain limitations when explaining more task-oriented dialogues. This finding implied that adopting hybrid approaches may be necessary for comprehensive and reliable explanation across various dialogue genres. Nevertheless, it's important to note that LERC provides a robust funding to further develop and refine our understanding. Thank you for your listening.